Hey students, thank you for joining me. I am Rajendra Bade. Today we are going to study what exactly a couple is with reference to a system of forces. Before you start solving problems on parallel system of forces or general system of forces, you must be sure about it. This is going to be a short video. Watch till the end so that when you start solving problem, you don't have any confusion at all about a couple. Two parallel forces which are same in magnitude, opposite in direction and parallel form a couple. So here is a couple. There is a couple acting on the rod because these are two equal opposite parallel forces acting on the rod. Now what is total force acting on the rod? Obviously 0. Now what is total moment acting on the rod? So let's check it. Let's find sum of moments of these two forces about point A. So sigma ma. So vertical force into horizontal distance. So moment of this vertical 20 Newton force about point A is 0. And moment of this vertical force into its horizontal distance, that is 20 into 2, moment center is A. So tilt this arrowhead on moment center side and with that direction anti-clockwise. Now I want to know moment of these two forces about point B. So vertical force into horizontal distance. So this is how you can write the moment. This is 20 Newton force into distance from point B, it is 10. 20 into 10 anti-clockwise, that's why positive, and moment of this 20 Newton force about point B is 20 into 8 clockwise. So it's 40 Newton meter anti-clockwise. Let's find moment of these two forces about this point, point C. So sum of moments about point C, 20 into 5 and 20 into 3. 20 into distance from point C, 5. It is anti-clockwise moment. And 20 Newton upward force, its distance from point C is 3. It is clockwise moment. And it's 40 Newton meter anti-clockwise again. And let's find moment about point D. And you will find it is again the same answer. So moment of a couple is a constant. It does not change with the change in moment center. Here are the two equal opposite parallel forces. How to find magnitude of moment of this couple? Magnitude of forces in the couple into distance between the two parallel forces. So F into D. Now watch here. Moment of a couple about different points remains the same. Moment of a couple means moment of the two forces forming the couple. So what is moment of these two forces about this corner of the screen? So same again, 40 Newton meter anti-clockwise. So we need not know moment center. So we need not mention the moment center when it is moment of a couple. And how to find magnitude? Force into the distance between the two parallel forces. And what about direction? So any one of these two forces, you just tilt towards the other force. For example, in this case, check here. Have you realized what is this direction? It is anti-clockwise. So this is how we identify the direction of a couple. Now watch, again it is the same rod, same couple acting on the rod, but we are going to move this couple closer to point B. Watch carefully the diagram. So here I have moved this couple now closer to B. Now the 20 Newton upward force is at point C and at distance 2 meters the 20 Newton downward force. So it is the same couple, only now it is closer to point B. Now let's check what is moment of this couple about point B. So moment about B, sum of moments of these two forces about point B will find out. So 20 into 7, vertical force into horizontal distance. Then 20 into 5, 20 upward force into the horizontal distance. And the answer you get is 40 Newton meter anti-clockwise. What you should understand from this example? A couple acting on a rigid body is a free vector. And one statement you have already studied, that is, a force acting on a rigid body is a sliding vector. What is this? Force acting on a rigid body is a sliding vector. This statement is known as a principle of transmissibility. If you don't know this, watch this video. Watch here, it is the same rod and the same couple I have shown. What is total force on the rod? 0. And what is total moment on the rod? 40 Newton meter anti-clockwise. Now here it is the same rod. But it's not the same couple, is it? Let's check it. These are the two forces, each 4 Newton, parallel forces, opposite in direction, means it's a couple acting on the rod. So what is moment of this couple? F into D, 4 into 10, again 40 Newton meter. So this couple 20 into 2 is 40 Newton meter anti-clockwise. Similarly, this couple 4 into 10, 40 Newton meter, same magnitude and direction of the couple. That means these two couples are equivalent. Now let's check this example. Yes, here again a couple acting on the rod. 16 Newton downwards at 30 degrees and 16 Newton upwards at 30 degrees. So two equal opposite parallel forces. So it's a couple. So what is moment of this couple? Let's add moment of these two forces about point B and check it. So sum of moments about point B. So 16 sine 30, remember 16 sine 30 into 10. So this force has two components at point A. Horizontal component has 0 moment and vertical component 60 sine 30 into 10. Now here it is 60 Newton force. Its moment will write. Again, its horizontal component is passing through point B. So moment of horizontal component is 0. Moment of vertical component 16 sine 30 into 5. This force is upwards. So upward force when you tilt towards B, it is clockwise moment, negative. And this force is downwards, it's anti-clockwise moment, positive. So total moment about point B of this couple is 40 Newton meter anti-clockwise. So yes, it is equivalent to this couple. Now, we have not used that logic. Moment of a couple is magnitude of the force into distance between the two parallel forces. So what is distance between these two parallel forces? Let's check it. I've drawn here lines of the two forces and perpendicular distance between these two lines. Let's find out. So focus on this right angled triangle. Hypotenuse is 5. So opposite side is 5 sine 30. So moment of a couple is F into D. This logic we are going to use here. So sum of moments about point B is 16 into 5 sine 30. It is 40 Newton meter anti-clockwise. So we say that these three couples are equivalent to each other. So what you should understand from this example? A couple can be replaced by a couple. A couple can be replaced by a couple in infinite number of ways. But remember, couple cannot be balanced by a single force because couple is zero force. A couple is also called as a pure moment. Here we say a pure moment is acting on rod AB. Here we say a pure moment is acting on rod AB. Conventional way to show a couple in a space diagram is its magnitude direction of its moment. So this is how a couple is shown in the diagram. So while solving problems on statics, parallel system of forces or a general system of forces, when you face a couple, remember these are two equal opposite parallel forces. We need not know which are those two forces. We need not know where those two forces are acting. We need not know what are the magnitudes of the two forces if we know magnitude and direction of moment of the couple.
That's it. Like, share, comment my video and subscribe my channel. Thank you.